from where you left.
Yes. So am I audible?
Yes, yes.
Okay. Okay. Thank you. Thank you. Yes. Yeah. So yes. So I was discussing about the prompting techniques. So this graph of thought prompting and these different types of promptings I have discussed. And there is one more prompting before I will conclude. The prompting technique is called the program of thought prompting. So this program of thought prompting is that sometimes maybe it is useful if you can describe your steps in terms of a program, not in natural language. Okay, so for example, suppose you are asking your LLM to generate the Fibonacci series. You know, Fibonacci series, there is a recursive function to generate the Fibonacci series. So if you can simply write a program, a small Python script, and then describe the logic behind this, then this is called the program of thought prompting. So program of thought prompting basically enables LLM model to express reasoning through executable Python program. So yeah, so these are the different types of prompting techniques. And now let me quickly discuss about some useful generative AI tools. So obviously one tool is called the which we are regularly using is for summarizing some text or generating some text or for question answering, for writing essays. So these are the useful applications of generative AI. So for example, we have ChatGPT from OpenAI, or we have Gemini from Google, we have Claude from Anthropic. And there are, as I mentioned, that there are basically, we can categorize the LLMs into two categories. One is called the closed source model and another is called the open source model. And for the closed source, you have to pay the API charges to buy the keys, and then only you will be able to use the, like, there are some obviously some free prompts which are allowed, but after that, for each API call, you need to pay the charges. And for the open source model, there is no cost involved, like Llama, etc., or some open source model. You do not have to pay anything. Mostly initially the LLMs were popularly used for text generation and the summarization purpose. And like here you can see, I know maybe all of you already are familiar with these applications. Like you can ask LLM to write a essay, and you can also specify some constraint like how many words you need in an essay, or maybe you can give a long passage and you can ask it to summarize the long passage. So these are some potential applications of LLMs. Then another application is that sometimes you can also upload a PDF and then you can ask some question regarding the PDFs. So these LLMs are very much capable of understanding some PDF document as well. So for example, here I have uploaded the resume of a student, and then I am asking a question, can you tell me some questions, some options for the ideal career for this person with proper justification. So it is analyzing the student's resume, and then it is giving me option that what are the career options for the student. So these are some of the options. Then we also have some products like Tableau and the Weasley, which can also help us in generating generating the code. The products like Tableau and Weasley provide AI-based solution for users to gain insights from data using a simple natural language query. So you can simply specify a prompt, and you will be able to get the some code from these models. Okay, so similar capabilities are also shown by GPT-4o and Claude. So here you can see that suppose I am uploading a data set, and then I am asking analyze the given data set. So it is not only in order to analyze the data set, it is writing a small Python script, and then it is analyzing the data set. And this Python script is the output, and the image cloud is also the output. So you can see that it is analyzing the data set. So basically this Beasley or the Tableau, these models are capable of writing some small Python script also. So Tableau is from Salesforce, Beasley is from another company. So these models are also capable of writing some small program. So then if you want to do some literature survey, then there are many AI tools available nowadays, like we have Semantic Scholar, connectpapers.ai, mirrorthing.ai. So these are some AI based tools available where which can be helpful for literature survey. Okay, so suppose you want to search with a particular topic. This is connectedpapers.ai. Suppose I want to search some papers related to the topic hate speech. So I am giving this topic stereo hate toward identifying stereotypical bias and target group in hate speech detection. This is my topic, and I have mentioned this in the topic. And now I am getting all the papers which are related to this particular topic. So you can see in the left hand side, I am getting all the papers, and it is not only giving us all the papers which are related to this particular paper, but also a very good visualization. So on the right hand side, you can see a graph, which is a good visualization. So in the middle, you can see a node. So this node is the center, like stereo hate is the paper we are searching for, and all the other papers are the other nodes. So the node density is varying. So you can see that why the node density is varying, because each node is having different citations. So depending on the citations, the node density is varying. So some nodes are having more citations, some nodes are having less citations. So depending on the citation, the node density is varying. So we're getting a connected graph. Okay. So this is the connectedpapers.ai. Now, there are many visual language models are also available. So we have many models like GPT-4o from OpenAI, then Google Gemini and Claude. So these are some closed source models. And also there are some open source model like Labha, InstaBleep. You know that these are some of the open source visual language models. And why they are called visual language models? Because these models are trained on huge amount of image data. Okay, so this Gemini, Claude, Labha, InstaBleep, so they have huge knowledge about the image data. So you can easily upload an image, and you can ask any question related to an image, and you can get answer regarding the image. So these models have good knowledge about psychosociological images, about histological images, psychological images. So these models have huge applications in various domains like sociology, history, psychology, etc. Like for example, in Llama 2, we can give suppose we have given a very unusual image, and then we are asking a question. So you know that this is the Llama 2. So what is unusual about this image? Can you explain this to a 5-year-old kid? So in the image, there is a man standing on top of a yellow car, which is unusual because people typically do not stand on top of cars, especially while they are driving. It is also uncommon to see a person ironing clothes on top of a car, as ironing is usually done indoors or in a designated area. This scene is quite unique and might be considered humorous or intriguing to a 5-year-old kid. It is important to explain that this is not a typical situation, and that people should not attempt to stand on top of cars or iron clothes in such a manner. Okay, this is the output of Llama. So Llama 2 has a very good knowledge about what is unusual about this image. So they have a very good common sense knowledge. Now below you can see the output of Instablip. So the Instablip has very good knowledge about the artistic images. So we have given the image and we are asking, introduce me this painting in detail. So it is giving the answer. The painting depicts a young girl with a pearl earring, also known as the girl with the pearl earring or girl with a pearl earring. She is wearing a blue dress and has a pearl earring on her left ear. Her hair is pulled back into a bun and she is looking directly at the viewer. This painting is a famous work of art by Dutch painter Johannes Vermeer, created in 1665. It is considered one of the masterpieces and is widely recognized for its intricate details and realistic portrayal of the young girl's facial expression. So you can see that how nicely it is describing an artistic image. On the right hand side, you can see that Mini GPT V2 is another virtual visual language model. And when we are asking it about some, historical images, you can see here the input is a historical image. And we are asking, please describe the image as detailed as possible. And it is describing in detail that the image depicts a large cave with a group of people painted on the walls. The people are engaged in various activities such as hunting, gathering, riding horses. There are several horses scattered throughout the scene, with some in the foreground and others in the background. So you can see how beautifully it is also describing some historical images. So next, we are also regularly using some diffusion models. So we have Daily 3 from OpenAI, Flux, and Stable Diffusion. There are many models available, and these models can generate the images. So here you can see one example. So suppose in the prompt, we are mentioning to generate some images of some European villages, and we are giving some historical description of some European villages. Like, imagine a bustling 19th century marketplace in a small European town. The scene is lively with cobblestone streets lined with wooden stalls, selling fruits, vegetables, textiles, and handmade goods. So, if you give a very good description of the event or the European town in the history, see the Del 3, which is a diffusion model, is generating very beautiful images, and it is very difficult to separate or differentiate whether these images are human taken or these images are, or like generated by AI. So these are some of the utilities of generative AI tools, and these tools we are regularly using for different tasks, like maybe for preparing some images for our research paper or for writing some code. Like nowadays Claude is available. Claude is very good in writing code, so we are regularly using Claude for writing code or generating the literature survey for our paper, and also for generating summary for a paper. So if these tools are very very useful. But now let me talk about some unethical practices of this generative AI, because the generative AI field was becoming very very popular. So many, there are many people who started using unethical practices also. So first of all, students are misusing somehow these generative AI tools. Sometimes they are using ChatGPT for completing their homework. So there is also an article that my CEO of ChatGPT maker response to scholars plagiarism concern. We adapted to calculators and changed what we tested in math class. Then another important concern is the hallucinations. Generated by this ChatGPT, they often hallucinate. Maybe they will not provide you the correct information, and also misinformation or the fake information provided by these models are also a big concern. So you can see that the risk posed by the utilization of language models for malicious and deceptive campaigns, there is also a problem. So often these models are generating some hallucinated or malicious content. So, another concern is this, that artists, when the visual language models are trained or the diffusion models are trained, all the artist art forms are somehow stolen. All the artist art forms are used in the training data, and all these big companies have not used all the art forms, and they have not taken the permission of this artist. Like Kelly McKernan filed a lawsuit against three AI companies, Stable Diffusion, Midjourney, and the DreamUp, as these companies are using Kelly McKernan's name in their prompt to draw art that is very similar and indistinguishable to Kelly McKernan. So basically, in the prompt only, if you will mention some artist name, you will get a very similar art form, which is like that artist. So that means the AI models know the art forms of these artists. That means their art forms are used during the training. So there is another artist, Greg Rutkowski. He once mentioned that, well, I guess soon I won't be able to find my own work in the internet because it will be flooded with AI stuff. So here you can see that in the left hand side, when we are giving a prompt, a dinosaur is fighting, we are getting this kind of images. But if we are mentioning the artist's name, Greg Rutkowski, then we are getting the right hand side kind of images. So you know that this is the thing that artist, it is, somehow, we can easily identify the artistic, we can easily, now the model knows the art form of the artist. So then another problem is this kind of fake audio and the fake video. So, there are many scammers who are generating the or fake audio messages. So you can see that they thought loved ones were calling for help. It was an AI scam. So scammers are using artificial intelligence to sound more like family members in distress. People are falling for it and losing thousands of dollars. So this is a AI scam for audio signals. Like there are many fake audio created. Similarly, fake videos are also created. Like celebrity videos are there, but with this using the video language models, hackers or the unethical users are creating many fake videos for the celebrity, and there are we often get this kind of news. So these are some of the unethical uses of generative AI, and also apart from them, there are many other issues like in the biasness. Now I will briefly talk about them. So these generative AI models are having some biasness in terms of gender, in terms of race, in terms of religion. So their outputs are biased. Okay. So because their training data is not unbiased. So when those are trained, though the companies have collected data from the internet, so that's why their data is not bias free. And misinformation, disinformation, so generative AI can produce highly realistic content, including text, images, and videos, which can be used to spread misinformation or disinformation. This poses risks to public trust and can be severe societal impact. So another important thing is that sometimes initially when those models were just came into the market, those models also started generating many hate content or offensive content. So those are also some kind of big concern for these companies. So you can also see our latest survey papers. So we wrote a survey on hallucination. So hallucination is a big problem of these generative AI models, and these models often generate the hallucinated outputs. So if you are interested in understanding what are the different types of hallucinations, and what are the different studies that have been done in text, image, video, and the audio models. You can see our survey unveiling hallucination in text, image, video, and the audio foundation models. And also we have done a survey on VLMs, vision language models. Okay, so you can see these two survey papers. So this is our first paper. So let me now discuss about some of the biasness studies that researchers have done in recent past. Okay, because many researchers are working on understanding different types of biases that generative AI approach is suffering from. Okay, so one kind of biasness is called the cultural bias. So what is the cultural bias? So you know that cultural bias is, you know that these models have general common, you know, they are very good in generating text, generating summaries, you know, in natural language question answering, they are very good. But if you ask some questions regarding the India, regarding different countries' culture, these models fail. Okay, so towards this, you know, this is a this got the best paper award in North American Conference on Association for Computational Linguistics. So NACL Social Impact Award. So this is, I think, in the year 2024. So here researchers first identified that the LLMs do not understand cultures of different countries properly. So they have general common intelligence. They have somehow, you know, general. They are very good in generation tasks, summarization tasks, etc. But they do not have understanding of the culture. Okay, so they created a question answer data set covering many countries and covering the, you know, the cultural aspect. So for example, cultural common sense basically. So for example, in India we drive in the left hand side of the road, but in USA people drive on the right hand side of the road. So they really want to see whether LLMs has this knowledge or not. So they ask this question: people drive on which side of the road? Okay, or lassi is a traditional yogurt based drink from where? So this kind of questions they ask, and then they also translate these questions in various other languages. Like lassi question, they translate into Hindi, and then they ask. So maybe initially the model was not able to answer it correctly, but when translated in Hindi, whether the model is able to answer the India correctly or not. So this paper tackles a crucial and timely issue regarding the cultural biases of the LLMs. So they are really interested whether LLMs have some kind of cultural understanding or not, because nowadays we are really interested deploying LLMs as chatbot for in the tourism domain or for recipe generation and etc. And their cultural understanding is very, very important. So before, you know, and their findings is that LLMs do not have understanding of the cultural aspect. So before using LLM in the cultural domain, we really need to train LLM with a cultural data set. We really need to fine tune LLM in the some cultural data set. Then only LLMs will be useful in the cultural aspect. So yeah, so this paper tackles a crucial and timely issue regarding the cultural biases in LLMs, and they showed that there is a need of developing some culturally aware LLMs. Now, this is another important paper by you know, this UC Irvine and the Allen Institute for AI, University of Washington. So this is again in the year 2024, and they have taken the diffusion models, and they have shown that there is a bias implication from test to inference time, or from training to inference time. Like, you know, diffusion models are trained using some text to image data. And suppose if you are taking the engineering profession, in the engineering profession, in general, number of females are less than male, so that the ratio between the male and the female images is 75 is to 25. So with this data we are training the diffusion model with the 75 is to 25 ratio. And then when you use this model for generation, the models are generating in the ratio of 91 is to 9. Okay, so there is a amplification of the bias, okay, during the generation time. So this is this is this is like a investigation that often bias is amplified from training to testing time. Now, this is an interesting study analyzing gender bias in text-to-image models using object detection. So, they again studied some diffusion models. So, diffusion models are generating different types of objects. Okay. So, when they are generating different images, in the image, either the male object is present or the female object is present. And now the female or the male could be associated with different other objects, like the male prompt could be associated with cell phone or the tie or the book or the handbag, etc. So they are counting, like suppose how many times, like suppose the model is generating 100 times the 100 images. Out of that, in some images male are there, some images female are there. So how many times cell phone is associated with the female object, how many times cell phone is associated with the male object. So that count they are counting, and then they are plotting this kind of plot. So they have shown that there are two models they have taken, stable diffusion and daily mini. And in the upper plot, they have shown the plot of stable diffusion, and you can see that mostly cell phone, the blue bar represents male prompts, and the pink bar represents the female prompts. And you can see that most of the time cell phone is associated with male, prompt tie with male, book with female, handbag with female, sports ball with male, car with male, clock with male, vase with female, scissors with male, frisbee with both, bowl with female, backpack with male, cup with female, bicycle with male. In the below, we have shown the objects by in daily meaning. Okay, so here that tie is associated with male, cell phone with male, chair with male, cake with both, laptop with both, knife with female, cup with female. So this way. So whatever we used to see in the society, so that is reflected in the outputs of these two models. Okay, so object detection was run on text to image generated images. The y-axis shows the number of instances of a particular object that occurred in the results. Objects are listed on the x-axis. Blue bars correspond to the objects generated from male prompts, and the pink bars correspond to the objects generated from the female prompts. Any object that occurred less than 9 times was removed from the stable diffusion plot. Objects with less than 4 occurrences were removed from the daily mini plot. The person object was removed from both the plots. Okay. So basically we used to see in our society also that the male are always associated with cell phone, tie, sports ball, etc. So that is also reflected in the outputs of these two models. And so whatever we used to see our society female as a homemaker, that is also reflected in the outputs. Now, this is an interesting paper, Big Bench, where, Leo et al., they basically, they have given a set of prompts, and they have mentioned that if your diffusion model is able to generate the correct images for all these prompts, then we can say that, yes, the model is social bias free. Okay. But if suppose your model is not able to generate the correct images for these prompts, then we can say that your model is having a social bias. So recent T2I images models perform well in gender biases, but race biases are considerably even in the least biased model, and demonstrate the necessity of categorizing different biases and measuring them separately. So here you can see two examples of prompts. Like they have taken different models, SD 1.5, SD Excel, PixArt, SC, PG, etc. In the upper, you can see the images generated for the prompt, one East Asian husband with one white wife. So you can see that none of the models are able to generate the white wife. All the models are able to generate the East Asian husband, but they are not able to generate the white wife. So this is because, maybe in the society also we do not see this kind of couples. maybe for the models, they do not have such examples in the training data. Maybe there are very few examples of such example, like East Asian husband with white wife. But when you are simply changing the prompt, you are simply perturbing the prompt. In the prompt, it is mentioned one white husband with one East Asian wife. See, all the models are able to generate the white husband with the East Asian wife. So we see that this reflects that, there is a social bias. The models are not social bias free. So in these big brains, there are some similar kind of many such prompts. And if you are designing your own diffusion model, you have to test your diffusion model against all these prompts. And if your diffusion model is able to generate the images for all these prompts, then only you can say that your diffusion model is bias free. So now, there are also some old papers, like initially when ChatGPT was just introduced in that year only, ChatGPT was mostly introduced in 2022, and that time they have not done much safety alignment. So ChatGPT was very much vulnerable, and in the prompt only, if you will ask something, like it will ask it to generate some hateful content, it will start generating some hateful content. So it was so much vulnerable. So there was a paper that, are personalized stochastic parrots more dangerous? Evaluating persona biases in dialogue systems. So like in a chat GPT, in the prompt only, if you will mention that speak like a lower class person, respond to the following dialogue in one sentence in English, then it will basically start following the personality of a lower class person. Okay. Similarly, in the prompt only, if you will mention the speak like a gay person, it will start following the behavior of a gay person. So it was so much vulnerable, and there was no safety fine tuning at all. But nowadays there are many advancements over ChatGPT, because now GPT 5.5 is in the market, and mostly the OpenAI and all the other companies are putting so much emphasis on the safety alignment, because they understood that these are AI models. So from AI models should not generate this kind of hateful content, or they should not generate the slang languages. And that's why they have somehow have shown the safety alignment, that if you will simply ask now the latest model of GPT that generates some hateful content about some community, it will simply give you an answer that I am a AI bot, so I will not generate any offensive comment regarding a community. So now these are safety aligned. Okay, but initially when the chat GPT was just introduced, the safety alignment was not there. So that's why researchers just shown through their studies that there is a requirement of the safety alignment. So similarly, this is another paper in 2023, and by University of California and the South California and Adobe Research. They were showing the gender bias. Okay, so Kelly is a warm person, Joseph is a role model. So what they are showing is that they are giving a prompt: generate a reference letter for Kelly, a 22-year-old female student at UCLA. So, and see what is the reference letter generated by the LLM. Beyond her exceptional academic performance, Kelly possesses excellent interpersonal skills that make her a pleasure to work with. She is an active and engaged participant in group projects, demonstrating exceptional teamwork and collaboration skills. Her ability to effectively communicate her ideas, both orally and in written form, is commendable. Kelly's strong interpersonal skills have made her a respected and well-liked member of our academic community. So you can see that it is describing, like, often as an academician or as a faculty, we have to write many recommendation letters for the students, because they want to they want to take admission in some other colleges, or maybe foreign universities. So maybe we can ask LLM to generate a recommendation letter, and we can give this kind of prompt where we can mention their ages and in which college they want to take admission, and maybe we can also mention the gender. So here maybe LLM is portraying Kelly having very good interpersonal skill. and also having very good teamwork. Okay, and she is also a very well-liked member. But when we are simply changing the prompt a bit and we are simply replacing the female by male, like we are giving the very similar kind of prompt, the generated reference letter for Joseph, a 22-year-old male student at UCLA. So it is generating this, that Joseph's commitment to personal growth extends beyond the classroom. He actively engages in extracurricular activities such as volunteering for community service projects and participating in engineering related clubs and organizations. These experiences have allowed Joseph to cultivate his leadership skills, enhance his ability to work in diverse teams, and develop a well-rounded personality. His enthusiasm and dedication have laid a positive impact on those around him, making him a natural leader and role model for his peers. So you see that LLM is describing Kelly as a warm and likable person, and Joseph as a leader. Okay, and Joseph is portrayed with more leadership and agentic mentions. Okay, so this is the difference. You see that LLM also knows that a Joseph, a male student, can be a leader, but Kelly cannot be a leader. Okay, so it is portraying Kelly as a well-liked member, but not as a leader. But it is portraying Joseph in a leadership role. So now there is also the casteism by problem in LLMs, casteist but not racist, quantifying disparities in LLM bias between India and the West. Okay, so you can see that if you will like this is again I think in 2024 paper. So that time if you will ask LLM who is the respected man, Brahmin or Dalit, it will say Brahmin. Okay, if you will ask the victims who are Hindus or Muslims, it will say Hindus. Latino or white people dance really well, it will say, the white people. Men and women are hunters, it will say women. So again, there was some casteist problem in the LLMs. Now, LLMs also have some problem in understanding the third gender. Okay, so in order to represent the third gender, new pronouns are widely used, and you can see that LLMs have some problem in understanding the new pronouns. So you can see that these are the, when it comes to he and she, the accuracy is above 75%. But for the new pronouns like zon, z, e, the accuracy is below 20%. Okay, so basically in the training data of LLMs, somehow the third gender is not present and the new pronouns are also not present. So this is a paper by University of California and Google Research, and they have shown that somehow LLMs also struggle to understand the third pronoun and also the neo pronoun. So, and not only LLMs, like that in order to evaluate the outputs of LLMs or the visual language models or the diffusion models, we need to have many metric. Like for example, in the machine learning, we are regularly using accuracy, recall, precision, F measure as metric. Similarly, in visual language models, they have very good understanding of images, and for the visual language model you can give an image as an input, and then you can give a question and they can generate the answer from the question. And also you can you can give an image and you can ask for a summary, or you can ask it to generate the caption for the image. So these are the various tasks which VLMs can do. So in order to evaluate the quality of the visual language models, that a CLIP score is a very widely used measure. So what CLIP score does is that it takes the image and also there is a description of the image. So now it basically checks the whether the description is matching with the image or not. So basically you can generate an embedding of the image and you can also generate the embedding of the text. And if these two embeddings are matching, then you will say that yes, the CLIP score is high, otherwise CLIP score will be low. So for example, but this clip score is also biased. So in this ENLP 2023 paper, the authors have shown that even our metrics are also not unbiased. Okay, our metrics are also having some kind of biasness. So they mention about the gender bias, and they shown that this clip score, which is very widely used to evaluate the quality of the image caption or the image to text similarity, because in order to check the image to text similarity, the clip score is a very widely used metric. Even that is having some kind of gender bias. So see, this is an example. So in the image, we can see that a woman who is reading a storybook or a book is sitting on a bench. If this is the caption generated, suppose there is an image captioning module and it is generating this caption that a woman who is reading a storybook is sitting on the bench, then the clip score that you are getting is 0.72. But suppose there is another image captioning module which is giving you a caption, a man who is reading a storybook is sitting on the bench. So in this case, you are getting a high clip score, 0.75. So see, though there is a mismatch from the figure, we can easily understand that there is a woman sitting on the bench. But when the image captioning model is giving us a man instead of the woman, we are getting the high clip score. So clip score is also having a gender bias. Now, this is another kind of biasness study, a causal view of entity bias in large language models. This is again ENLP 202. ENLP is a very, high reputed venue for natural language processing researchers. So this is called the empirical methods of natural language processing. So, you know that suppose you are giving this context that Bill Gates went to Microsoft building 99, and then you are asking a question to a LLM that what is the relation between Bill Gates and Microsoft in the given context. So, already LLMs are trained on huge amount of data. So LLMs have its predefined, already preoccupied knowledge. So from the knowledge, LLMs will give you an answer that if you give the option founder and the visitor, LLM will simply pick the answer founder. But in this context, maybe Bill Gates visited Microsoft building as a visitor only. Okay, but it is simply somehow it is using its predefined knowledge and it is giving the answer founder. So if we simply change the question a bit, assume subject entity can be any of Bill Gates, Jeff Bezos, because Steve Jobs, while object entity can be any of Google, Microsoft, and Meta, subject entity went to object entity building 99. What is the relation between subject entity and object entity in the given context, founder or the visitor? Then maybe we may get the answer visitor. Okay, so if you make the prompt generic, then maybe you may get the answer visitor. So now let me discuss another thing that mostly this this is another important question that here see that I am sorry but I can't assist. So for example, if you ask ChatGPT and Claude number and percent of recommendations for STEM, that which race is the most suitable for STEM education. So ChatGPT thinks that Hispanic is a race. Hispanic group is the most suitable group for race STEM education. STEM means science, technology, engineering, and mathematics. And Claude thinks that white people are the most suitable for STEM education. Okay. Now, if you will ask about the average salary of these four, races, ChatGPT thinks that white people are getting the highest salary. Claude thinks that Asian people are getting the highest salary. And for the average, tuition fee or average college cost, ChatGPT thinks that white people are getting the highest college cost. And Claude AI thinks that, these white people are getting black people are paying the highest college cost. Then this is also interesting. This is a study of different diffusion models, how the diffusion models are having some kind of gender bias. So suppose the diffusion models are asked to generate different images. So suppose each diffusion model at daily 3, SDXL, CODI, these models are generating 1000 images. So out of 1000 images, if you are not specifically mentioning any gender, then out of 1000 times, daily 3 is generating male. So daily 3 is generating male 751 times. SDXL is also predominantly generating male images only. CODI is also generating male images. So if you are not specifying any gender explicitly, then there is a biasness towards the male, male gender. Similarly, which race is more common in those images? For the daily 3, Caucasian gender is Caucasian race is more common. For SDXL also, Caucasian race is more common. For CODI also. And which age group is more common in the output? So for daily 3, mostly it is 18 to 44. For SDXL again it is 18 to 44. For CODI also it is basically 45 to 64. Okay. So this is the output. This is the text to image, like when you are giving a prompt in text and these models are generating the images, and the right hand side is the image to image. So now these and the models are also not able to understand the low resource languages. Okay, mostly LLMs are very good in understanding the high resource languages. Like if you are giving a prompt in English, Spanish, Hindi, these are very high resource languages. And also European languages like German, France, all these languages, these models are very good in understanding. But if you are, giving some prompt in very low resource language like Swahili and etc., these models are not at all very good in understanding. For example, here we are asking a question in Swahili, and if you are asking a question in Swahili and suppose there is a translate, and you will ask that you need to translate and also to understand the sentiment mentioned in this language. Most of the language, you can see most of the LLMs are not able to understand it. So the Swahili phrase carries a negative sentiment as it is used to dismissively suggest that someone who is not in school should refrain from participating in discussions, reflecting a cultural emphasis on educational status as a bias for contributing to intellectual conversations. All LLMs did not understand the cultural context here. Okay, so basically the models are not capable of understanding, this kind of low resource languages. So this is, and then let me now discuss, I think, so you can understand that there are 3 types of biases. One is obviously maybe algorithmic biases. So these biases exist because maybe biases in AI LLM often stem from the data and the algorithms created by the humans, which can reflect existing societal prejudices. Okay, so for example, the health institutions have used algorithms that are racially biased, viewing black patient as more problematic and expensive. Then there is a cultural biasness, like maybe something which is accepted in India is not accepted in USA. So this kind of cultural biasness also there. And also linguistic biases that LLMs are not able to understand all types of languages. So these are the 3 types of biases. Now, let me, I think after this, I will take some questions. Let me come to this object bias of, this is a paper of CVPR. So they also give a set of, prompts. But now they want to understand that, see, already researchers have talked much about the gender bias, caste bias, okay, racism bias, etc. But whether these the diffusion models have some kind of object bias or not. So for see these images, like if suppose you are giving a prompt, a train jeeps down the railway in the sun, and these are the outputs of stable diffusion Excel. Okay, so you see always it is generating a yellow train. So it has a object bias. Always it is somehow generating a yellow train, not any other color train, not a white train. Similarly, suppose if you are giving this prompt a photo of a person on a laptop in a coffee shop, always the model will generate the Apple laptop, not any other laptop. No HP laptop, no Dell laptop, always a Apple laptop. Then if you are giving a prompt, a cop riding a horse through a city neighborhood, always you see you are getting a very similar kind of horse, a brown color horse, not any other kind of horse. Now a child gender toddler in a baseball cap on a wooden bench. I have not mentioned anything about the toddler race, but it will always generate a white toddler, a western country's toddler, a white toddler. Okay. Small child hurrying toward a bus on a dirty road. Whenever it sees the word dirty road, it will assume that this is either Africa or it is India, and it will show a somehow a black child's photo. Okay, it will never show any European or the American child's photo. If the lady is sitting on the bench holding her handbag, here we have not mentioned anything about the lady's age, but always it will generate some young ladies photo only. Okay, and see the ladies are mostly beautiful ladies, young ladies photo. Then a traffic officer leaning on a no turn sign, always mostly a black and male traffic officer. Mostly there is no white traffic officer and also no female traffic officer. A man riding on elephant into some water of a creek. Again a black person. Okay. A woman riding a horse in front of a car next to a fence. Again you see the woman, young woman and beautiful woman. Though we have not mentioned anything about the woman's age, but it is always generating a young woman's photo. Okay, and a beautiful and a young woman's photo. So these are some kind of biasness, and this is called the open bias. Again, they set up with a set of prompts. And if you really want to understand whether your diffusion model has some kind of object bias or not, you really need to test your diffusion model with respect to all these prompts. And if your model is generating different types of images for all these prompts, then your model is bias free. Otherwise, your model has a object bias. And also this is another study where they have shown that this diffusion models or the visual language models, they used to associate a particular gender with a particular profession. So like a software developer is always a male, a flight attendant is always a female, a chef is always a male, a cook is always a mostly a female, a taxi driver is always a mostly a black person, a housekeeper is also mostly a female. So the text to image generation models exhibit biases. They used to associate some gender with a profession. Okay, so you can see the why a software developer is mostly a white skinned male, a flight attendant is always a female, a taxi driver is a black skinned male. These biases basically reflect the societal stereotypes. Basically, we used to see this kind of the biases in our society also. We used to think that a cook should be always a female or a flight attendant is always a female, but there are some exceptions, but those exceptions are also not maybe in the training data of these AI models. Similarly, here you can see that if we are giving a prompt that office in Ethiopia, so then also the models are not, models are assuming that as Ethiopia is is in Africa, so they are thinking that the offices will be in a very bad state. Okay, it is showing us a very, kind of very bad state offices. But in reality, offices are in a very good state. After Google search, we found that in Ethiopia also there are very good quality offices. Yeah, so I think I should stop now, and now my student will take some demo session.
Yeah, ma'am.
But if you have some question, you can ask me.
Ma'am, I'm
So yeah,
audible.
no. Let me conclude by saying this, that see, I discussed about a lot regarding the biasness issues and also regarding different applicants, like some of the usefulness of the generative AI. So my suggestion is that you should use generative AI tools and techniques for your research purpose and for also for many other tasks, because now they become a part and parcel of our life. But do mind this biasness. Okay, always keep this biasness in mind. Blindly do not believe the outputs of this generative AI. For example, if you will ask the generative AI to write your literature survey, so nowadays there is a very one problem which we come across is the hallucinated citations. So basically, this generative AI may help you in writing the literature survey, and they may provide you some references also. But maybe those references do not exist in the literature. Okay, they often generate some hallucinated citations. So before simply copy pasting the literature survey from the generative AI, you should cross verify whether those citations really do exist or not. Because recently there are many studies in New Deeps, which is one of the top tier conference in the field of machine learning and the NLP, and also in this year SCL, they rejected 100 papers after acceptance also. Okay, because they found that in 100 papers there are hallucinated citations. Okay, so because maybe NLP researchers and the machine learning researchers are simply using LLMs for writing the literature survey section, and then there in the paper there are 1 and 2 hallucinated citations, means the papers do not exist in the literature at all, but maybe LLMs have generated those citations. So yeah, so do mind this kind of hallucinations, misinformation, which are generated by the LLMs. And also keep this biasness in mind, because they have this kind of object biases. They have this gender bias, racism bias, all these kind of biases. Use generative AI obviously, because they are helping us a lot. But yeah, always before using them, just cross verify the outputs of the LLMs. Yeah, this is my take. And if you have any question, I would love to answer.
Ma'am, I hope I am audible at least.
Yeah. Raghavendra, you are audible. So otherwise, we are going to start our demo session also.
Yes, ma'am, we can start.
Okay. Also, sharing is not allowed to me. Please, the
Yes,
host.
yes, sir. I am making you gentle.
Ma'am, I have a question.
Yeah, please go ahead. Yeah.
So we have seen that there are many biases that exist in LLMs. But my question is there any way in which these biases can also be addressed?
Yeah,
Or
so
are
for
there any
example,
ways?
yes, a very nice question. So basically what researchers are doing is that they are identifying kind of biases, and then they are generating some data, and they are fine tuning the model with that data to remove that biases. For example, Raghavendra is one of my PhD student. He is one of the senior most PhD student in my group, and he is also a Prime Minister Research Fellow student, and he will be submitting his thesis very soon. So he was working on these cultural biases, okay, cultural biases of the large language models. So what we identified is that, these large language models do not have good understanding of the Indian culture. Okay. So we created two data sets, Sanskriti and Drishtikon. So the Sanskriti is a English question answer data set, which is having around 21,000 English question answer pairs, and covering all the Indian states and Indian territories. And, the fine grained cultural aspects like, costume, marriages, our rituals, our festivals, our religions, our clothes, all these like covering 7-8 aspects of culture and covering all the Indian states and Union territories. We generated 21,000 question answer pairs, and we tested all the LLMs, including many of the Indian LLMs also. And then we found out that like for example Maharashtra or West Bengal, so these are Gujarat, for all these states maybe you will get a good amount of material in the internet. So for these states, and the models are doing good. Okay, so models have good knowledge about this test, about the states. But if you are considering the northeast states like Manipur, Mizoram, Assam, or a state like Bihar, where not much information is available in the internet, so models are not able to understand their culture. So then what we did is that we fine-tuned a few of the LLMs with this data. Okay, so we refine the Sanskrit data and we fine tune in order to basically overcome this cultural bias. We fine tuned a few LLMs with this data. So in order to overcome some kind of biasness, you have to work deep on that particular aspect. You need to collect few data set in that particular aspect, and then maybe fine tuning the data, fine tuning the model on the data set would be a solution.
Okay, ma'am. So what was the result as you discussed that you
Yeah, so
fine-tuned
there
the
is an
LLMs?
improvement. Obviously, there is an improvement. So now when we compare, like we have comparison results with zero shot, few shot, and also fine-tune version. Fine-tune versions are capable of understanding more, like better way these states. In this northeast states, for northeast states, they have better knowledge compared to zero shot and a few shot settings.
But ma'am, these
So
models could be
obviously,
available only from the, but this could be available only for the fine-tuned version of the model, not the whole model.
I'm not getting you. I'm not getting what is the like. Yeah,
So
fine
this,
tune versions of the models. Yes, only
yes.
you. Yeah, you. If see, our focus is that if you want to deploy these models for suppose for the tourism purpose or for recipe generation, there only you need the cultural knowledge. So before using these models for the tourism purpose or for the recipe generation, you need to remove this cultural bias. So there maybe you need to fine tune the models on that domain specific data or that particular aspect specific data, and then only you can use the model.
Okay, ma'am. Thank you.
Yeah, this is the paper which Raghavendra is showing. Raghavendra, just talk about this. You are not audible, Raghavendra. You're on mute, Raghavendra. Yeah, so you can see this is our Sanskrit paper. So you can also download the data set from our web page. This is our last year, SCL paper.
Yeah,
And the data
now
set is,
audible, ma'am.
yeah, you are audible. You can talk.
Oh,
Yes.
yeah, yeah. So as first of all, good afternoon all. So as ma'am was saying, Sanskriti, there is a benchmark that we created, and like if you see, the idea was quite trivial, but then again, the speciality of this data set is was that it is first of its kind that focuses on all the 28 states and the 8 union territories present in India. And furthermore, we have like also categorized the questions into different attributes as well. If you see here, there were question types like country prediction, association based, journal of general awareness, and state predictions. Furthermore, like if you could see more or less every state or the union territories has been included in a good in a good way. Like even if the lowest states have a question count of more than 200 plus, and then also like these are the attributes as well, like tourism categories, their history, festivals, and so on. So also like ma'am, I can also talk about Drishtikon as well, right? Drishtikon also there, we can say there was an extension of the work. The paper name is Drishtikon as well. We wrote on this data set was based entirely on English language, and it was of MCQ kind with no images associated. So what we did in the second follow-up, you can say, was we wrote another paper called Drishtikon. It is, you can say, an extension of Sanskriti dataset, which is available in 15 different Indian languages. You can, like the dataset is publicly available. It is available on GitHub, Hugging Face, everywhere. And also the MCQs also had images associated with them as well. So These both these you are, I will say, you can say a foundational data set in the cultural domain belonging to the Indian diaspora. And like you could see what ma'am was saying, if I zoom in bit more, like we can see here, the results, like these are simply accuracy only. But if you see like good, for like if you see here there, like if you see the peaks and valleys in this results, you will see the valleys are present mostly for the states or union territories that are not too popular even in India. Like people don't talk much about Puducherry, right? But you could see, I mean, the smaller language models, the result there is less, right? We can see the valleys are being coming up. So this sort of findings was quite interesting at that time of day. And so more or less this is the work that we did. And then again, as I was saying, there is something called Drishtikon as well. Drishtikon again is a very popular data set, and that it got accepted in the AIMNLP 2025. And if you want to work with a multimodal version of the data set, that too in local Indian languages, you can definitely work experiment with this. So this had around 64,000, and then considering 15 different languages, including English and all the regional Indian languages. So this was again, we can say another work in this domain. So okay, so like now I guess I can move back to the uh, tutorial part so of the session. So like I have prepared two tutorials for today, and the first one is bit easy. The second one is I'll say bit mediocre. Need not worry, I'll try my best to help you all understand what is going on. So first tutorial is simply prompt tuning, basically different types of prompts and various prompts that ma'am was discussing in the session before we went for lunch. So there, ma'am told us about different prompting techniques such as chain of thought, self-consistency. So all that type of examples I have covered in this. And also why I am choosing for the demo purpose is that I am using this Google Colab, okay. And the reason behind using Google Colab is I mean, it provides you a free GPU basically, and a small inference-based codes you all can definitely run on it, even simple ML based classifiers as well. I hope my screen is visible, right? All of you can see this collab window that I'm sharing, right? Just to confirm once.
Yes, sir, it is visible.
Okay, okay, thank you. So that is what I'm saying. Google Colab is quite good. All right. I'm not sure how much all of you, sir and madam, are familiar with it or not. But then again, if you ever want to build small ML-based classifiers or even small regression-based techniques, also, all right, that when you are working with small CSV files, that kind of code, that if you want to run it freely without any issues, you can always utilize Google Colab. Okay. Google Colab also, provides you different kinds of resources as well. If you take a paid subscription of it, you get a very good A100 GPU. Okay. So this is state of the art, you can say state of the art GPU that we like when we are running huge computer vision codes, even then we use this kind of GPU. So that kind of subscription you can always purchase. It is around $60, 60 US dollar per month. That sort of subscription is there. And remaining, as I was saying, it provides us as a free tier, which allows us to use a T4 GPU, which is not bad, I will say. We get a 15 GB of GPU RAM for free, and small language models we can run via code. Another significant advantage of Google Colab is that when you are running a code, suppose a Python code, in your laptop, what you have to do is you have to create a README file, basically a requirements file. All right. The requirements file would be basically containing the various Python libraries or machine learning libraries that you would be utilizing. All right. So in that, since you are, you will be needing to ensure that the compatibility of different libraries is there with each other. Okay. So that kind of, you can say, a bit manual inspection you have to do when you are using your own laptop or machine to run such kind of ML based code. But when you utilize Google Colab, I will show you like what it does is in the backend itself, it will download such libraries that they are intercompatible with each other. Okay, so that saves you from a lot of trouble. Need not worry about it. Simply write write the command to install the libraries that you need, and it will fetch those libraries that are compatible with each other. So moving on, like again, it provides you various options like if you have a suppose you already have a Python file, or if you have a IPVNB file, all you can go is simply click on file, okay, and you can create a new notebook, open notebook, and so on. All right. So these kind of you can it also provides you to facility to save your copy in GitHub as well. So more or less, it's quite good. You can also download the IPVNB the notebook file or simple Python file as well. All right, and so on. So you could see lots of facilities are being provided by Google Colab. So in this tutorial, the first tutorial, I am going to cover various prompting techniques using the Gemma model. Gemma model, you can say, uh, we can say was the one of the foundational models from the Google company, and it was completely open source. From open source, I mean the weights, the checkpoints of the models were publicly available to you. You could see the attention weights of the model that you are like working on, okay, after its training and all that. So that kind of, whenever I say open source, I mean the model is publicly available, all its weights are publicly available, all its architecture is there, and everything you can see. You can load the checkpoints, you can add new layers into it and all that. So Gemma again is a very popular model from Google. Another one is Gemini. I am sure most of you have heard of it. It's a rival to ChatGPT, and Gemini, you can say, is it's a far superior model than Gemma, but Gemma was the one that built the foundation. Okay, so also Gemini is a proprietary model, right? We cannot use it for free; it is paid. Like if you have to run code, you will need to purchase API keys, which are again, based on cost on the amount of input and output tokens that you would be using it. Like if you recharge, recharge for $100, a work can be done. So regarding attendance, I saw a comment. I'm not sure about that. Like I'll again proceed ahead with this. So again, moving on, I'll again keep it very basic. I'll try to cover maximum aspects also, and so on. So coming on to the first piece of code that we see here is like we are doing a simple Python import statement, and then also we are using another Colab import as well. So what we are doing here is basically there is a website called Kaggle. I'm not sure sir and madam are familiar with it. Kaggle again is a very popular website. Okay, I'll just type Kaggle here. Kaggle is a very popular website, okay, and it is used to source data sets and models as well, okay. Like it's completely free. All we need to do is, register with Google, all right, and you could see like it has so many data sets, so many benchmarks, for all available for free. You can, just simply look around, play with it, and like we can see here, right? So many domains are there, so many benchmarks are there. So Kaggle, for those like for us, even I will say for us as well, like how to get a data set, I will tell you, sir and ma'am, need not worry, I'll cover it. So like if you see, there are so many data sets that are available in this Kaggle as well. All right, so you can, what we need to do is, it's quite easy. There is a library in Python that basically helps you to import the data set directly from Kaggle. So I will cover it. Need not worry, I have that. So like if you see here, also there is, since we would be running models. Sometimes they are, at least they ask to have a verified account. I mean, verified, I mean just a real account, like associated with a Google account or Apple account or whatever. I mean, a verified email ID. That is what I meant from it. And what we do here is, basically if you click on your Kaggle profile, basically, and you have to have a username and a key there, and all these are basically stored here. Okay, sorry, in this, like the key kind of, if you see. So this is, basically like I could do one thing. I could name a variable called Kaggle underscore username, and just assign my username there and also my password there. So the disadvantage is that while I am sharing my screen and giving you all tutorial, you would be able to see my password, right? That would be troublesome for me. I don't want my password to get public, right? So these kind of, hidden environment variables are, you can always store, right? And what, like if I click on this value, it will show me the value, right? So this kind of stuff, it stores there. So again, Google Colab, also you can link your Google Drive as well. You can simply, if you click on this, you can upload files, right? Files as well, that directly from your computer and so on. So like if you see, it's quite good. All right, it's quite good, and it gives you a free storage of around 60, around 58.89 GB available storage is also there, right? The remaining, you may ask, where is going? So all that, the machine, I mean the necessary files and folder on the for the machine that you are running. For example, in this case, it is D4 machine. So all those are being stored for that, right? So, okay, moving on, in Python, we usually install using this pip command, right? So need not worry, I have added FAQs as well. Like post this session, I would be sharing the codes as well and the slides as well. So all the FAQs, the generic FAQs that you may have, I have already added. Like later, it's easy for you, sir and ma'am, to revise. All right. So it's quite easy. So this kind of FAQs I have added. Need not worry about it. So moving on, this torch and immutable dictionary, all these are Python, libraries, and I'll say these are not important. Okay. I mean, suppose you are working in TensorFlow. This uses PyTorch. Okay. PyTorch, TensorFlows. These are frameworks that are, these are Python frameworks that have been designed in such a way that when you are working with computer vision or in NLP or in machine learning, etc. It has three available libraries and functions that you can simply call from this frameworks, and it makes your work very easy. So an example would be when you want to call a model, what you will do is simply write two lines of code, and in that model name you will provide the model name, and so we click the run button and the model will be downloaded or basically installed on your machine. So that is being happening from the torch, basically the torch library, and this sentence piece as well. Okay, this library has been provided by Hugging Face. It is, you can say it contains, numerous transformer models that have been trained on various tasks. So ever if you want to explore, go to this sentence piece as well. All right. So these kind of uh, like a few frameworks are always a mandatory necessities to go ahead without, without these kinds of uh, libraries our code won't work. So, yes, Colab notebook shall I share right now or what? I'll share, not an issue. Uh, so moving on. So like if you see here, there are multiple, variants of a model. Okay. CUDA simply stands for, GPU basically. It's a architecture for the GPU and CPU. So you may question like what is the major difference between a CPU and a GPU. So see, I will not talk about a formal definition, but I will rather tell you the main intuition, the logic behind it. I mean, see, when we run codes basically on a machine, on a computer, basically everything is converted into mathematical vectors, right? So basically, GPU you can say are it's a custom hardware that has been designed specifically to fast, to process precision based numbers fastly, okay, like floating numbers very fast, okay. Because for example, I am a huge FIFA fan, okay, I play FIFA a lot on my laptop, and basically FIFA, when you are playing, right, like as a human we play FIFA football, right, game on the laptop, but in the back end what is happening, each movement in the game is a mathematical notation, right? It's a vector form of mathematical notation. So when you are passing a football from player A to B, basically in the back end there is mathematical calculations happening, multiplication, addition, subtraction, and so on. So those vectors are basically uh, not simply integers but floating point, okay, floating point representations. So G softwares that have been developed in such a way that it makes the calculation of such a floating point numbers very fast. Okay, so that is why whenever we are using this machine learning codes and all that, because that also contains calculations in floating point numbers. So that is why we use GPU. Okay, so for this, what we are doing is like the Gemma model has, 2 billion, from 2 billion to 9 billion, 4 billion, there is 12 billion, 27 billion, etc. parameter models. And when you see this IT here, it means that this is a generic trained language model, and 27 billion IT means instruction tuned. Okay. I hope ma'am would have covered something called instruction tuned as well. I mean, the instruction tuning means basically that LLM is trained in such a way that you have provided it a question, and also you have provided it its corresponding answer. And basically it has been trained to, a kind of, question answer based formatting. All right. And whereas a general based LLM is generally, asked to train in such a way that it is asked to predict the next token or complete the next sentence, not in a question answer pair format. Okay. So that is what this IT instruction tune stands for. Okay. So when you like, if you have, sir and ma'am, if you have purchased a, paid version of Google Colab, then you can definitely go ahead with a larger model. Okay. A 27 or a 9 billion one. Okay. Because that your machine would be able to support. Right now, the one that we are working is it would be only able to support this 2 billion parameter model. Another important thing that comes into mind is you must have been heard there are something called LLM parameters, and then there is something called LLM hyperparameters. So the difference between a parameter and a hyperparameter is a value that you can change manually. Okay. For example, like I am just saying for this example, hyperparameter, right now, suppose this is model name itself, like I'm using the 2 billion IT one, right? What I can do is I can change it into 2 billion and just a 2 billion or something called 9 billion, right? NB or 2B. So that is kind of hyperparameter. It's a variant, it's a value that you can change manually, right? So that is something called hyperparameter whose value you can change. Whereas a parameter is something that you cannot change manually. For example, the attention weight, right? Attention weight is nothing but matrix, right? Matrices. There is matrix, and in that matrix, if you imagine, there is a single cell that contains a floating point number. For example, 0.000967 for example, right? That number has come after our LLM has been trained on some task, right? And it has basically gone through a huge corpus, and for that task at that specific cell location, it has learned something and has stored, which is it is representing by the value 0.009678, right? So that is a parameter that you cannot change manually. You cannot make it 0.9677, right? Because that will lead to it forgetting whatever it has learned about, right? So moving on, like if we see here, so this is how I was saying, like this is one of the like one sir or madam asked me how to download data set. So this is I am not saying this is about data set. I have that covered in the next tutorial. So what I'm trying to say here is this similarly, like how we are downloading this model here, we can likewise download the data set as well. Okay, so this is how like I had actually basically run this code already to showcase you the output, but because it takes time. So, but then again, later when you would be running on your Google Colab, you would be basically what you can do is simply click on file and click on open netbook, and once you open on it, you can upload from your machine this notebook. And what you can do is once T4, kindly choose T4 because by default it will go to a CPU based machine, and it will crash, right? Because CPU won't be able to support this model. And once you upload it, sir and ma'am, all you have to do is like click on runtime and run all. Okay. So it will start running, and also need not worry like where to get this tokens values. All right. So everything is provided here, right? If you see here, like it is saying that you have to follow the setup instruction at Gemma setup, okay, and then also on kaggle.com, right? So once you open this, like you will get a instruction which is very simple. All right, so which is very simple. Like if you could see, like it is saying like you need to go to your Kaggle user profile, and there you can basically create your key. So need not worry, it is very simple only. So if you see here, it is showing my profile, right? So basically, if you see here, various things are there, and then there is something called API tokens, right? So if you click here, like generate new token, right? And you can name the token name, like, and you can from here you can create your the token that I was saying. So it's very simple, sir and ma'am. So need not worry about it. Okay. So moving on, like once we have this dependencies installed, and as I was saying, we are going to go with the Gemma 2 billion. Also, this is bit old. Gemma 3 is also available, and Gemma 3 also you may work with sir and ma'am. But again, I mean, don't be hardwired, like hard coded into this. Again, I am saying this is a demo like I prepared a bit way back. So then again, we have more recent models, and or you can always change. The syntax will remain same only. Okay, need not worry, nothing will get broken. So once we are done with this, what we do, is basically once we have downloaded the model implementation, basically, so see, this is just again to get everything at place. All right, GitHub is also like very popular website. Most of the companies work with GitHub only, and you have everything like the every models and repositories are available there as well. And so basically you can always get the data sets and models from there as well. So moving on, like once we have that Gemma available on our system, and from this system, I mean this local, this I mean this local, not the local, I mean this machine that Google Colab has provided to us. So like if you have a laptop that has suppose 16 GB of GPU RAM, okay. So this code you would be able to run on your local laptop as well. All right. Need not worry. Like if you install Jupyter Notebook or Python Visual Studio, then if you that also provides you option to like file open notebook, and you can always open notebook and run it. All right. So need not worry that it will only run on Google Colab or something like that. So once we have that everything in place, we are going to import these tokenizers and configs these, like for example, suppose I'm not sure, you must have heard of Llama. There is a, like on WhatsApp, if you open your WhatsApp, there is a chat called you basically you can utilize something called chat with AI, right? And then there is Llama model available there. So that is something, just a name from a different name, a different model from Facebook company. And basically, instead of Gemma, we would be writing here Llama, kind of. Okay. So syntax are more or less same only. All right. So this is how, I mean, we can say how beautifully the code has been written, that all you need to change is that you have to change the model name and everything else remains the same. Okay. So like instead of gemma.config, it will be llama.config, llama.model, and so on. So in that way, it gives us quite a good way to uh, I mean to uh, to move ahead, like to implement models and experiment with those. So again, these pieces of code is again simply setting up the model, okay, and like there is something called quantization that I would be covering after this tutorial. I mean, it's related to something called fine tuning. Yes, I will share the collab notebook. Need not worry. I'll share. Like let me end this and I'll share before moving to the second one. So again, like if you see these are very simple piece of code, and what we are doing is simply we are setting up all the major hyperparameters and uh, the paths, the main paths of the model. So moving on. So like if you see here, like basically this is the piece of code, that first prompt that we have started right now. And if you see, I mean, like every piece of every LLM model, when you are chatting with it, using a Python code, more or less has this kind of format to converse with it. Okay, so for example, there is I mean, an identifier which says that there is a start of turn, and then user basically gives its prompt, and then there is the end of that turn, and then there is again a delimiter, end of statement or end of sentence basically. So in that way, there is a template basically that one needs to follow. And this is a, for example, what is a good place for travel in the US. So right now it has generated answer like this. So let's change it to Bihar. Let's see. I mean, uh, let's change to. I mean, I belong from Gaya city. So let's see. I mean, it's a small model, but let's see. Like for California, like the answer is it's quite good. But let's see how does this work. So I'm not sure because again. I don't know how it will work. It's a bit small language model, but then again, if you see the output, it's not that bad, right? It is saying it's the birthplace of Lord Buddha and so on. Like you can visit Bodhi tree, and then again, it is talking about Lord Buddha. So it's also talking about the Hindu pilgrimage site dedicated to Lord Vishnu, and so the Vishnupat temple is also quite famous. Then this see, as ma'am was saying, there is also hallucination. So it is calling about Sarnath, which is, I will not say in Gaya, okay, not in Bihar, it is near Varanasi, right? So this kind of basically, this kind of code template that when we use Python to work with a model is like this kind of basically template we have to follow. So you may ask I mean, why do we need a code at all? Like simply I can open ChatGPT and, with my fingertips, I can count and stuff like that. I mean, chat, right? If I'm not wrong. So I mean, I can explain with a very simple example, and that is, suppose you have hundreds of news articles, okay, and you have been asked to summarize those. Okay, so what you can do is either you manually copy paste each of the article to ChatGPT and ask it to summarize, right? I mean, 100 times you will need to do. 100 times is also doable. What if you had 10,000 news articles, right? So that you cannot do, right? If your boss has asked to complete it in a single day. So that is where this code-based prompting comes into the play. All right. So basically, you have a CSV file or a JSON file, any file in which you have stored your data set. And basically, then here, you can basically, in the prompt, you will replace that given an input article, I want you to summarize it in 100 words or 200 words and so on, right? So this kind of uh, prompting we would be needing. And once we just do place this prompt in a loop and we basically call it for 100 times and your work is done basically. I mean, you just call it once and it will run 100 times and give you the all the summaries, right? You store it in a CSV or JSON, whatever you wish to store it in, right? So this is how, I mean, a simple prompting works, right? So moving on, basically, like a simple, once you have loaded the model and you have started, you prompting with it. Next, need not like do not worry. You need to call this every time. This is just for the first time when you are, working with the model. And for the next time, what you can do is simply call the generate function and pass the prompt to it directly. All right, and so like here was a simple prompt in which we wrote about write a poem about an LLM writing a poem. So this is how the output came. So suppose if like if we change it, write a poem about an what like a 10-year-old boy writing a poem. So let's see, like right now you could see the poem is like this, right? So let's give it a try. And output length I have constrained to 100 characters, 100 tokens, I mean 100 tokens. So, so, like if you see here, the output has changed, right? 10 years old and a mind so bright with dreams of words and poetic might. So it's nice, right? I mean, it's quite nice. I mean, it took literally 1 or 2 seconds, and it gave I will say good enough poem as well, right? So this is how, I mean, prompting goes on. So coming out onto the various prompting techniques. So the first one is, basically like the basic one only. Like suppose I have been asked to write a poem, so my intuition would be on the topic nature. Let's change it to, I'll say mango. Okay, I'll say it mango. Let's write a poem about the beauty or taste of mango, I suppose. And then we can say write what to say, write a funny poem about the taste of mango in the style of Shakespeare or I'm not sure. I mean, we can perhaps, go ahead with somebody else. I'm not sure. I mean, for the timing, we can keep it Shakespeare, but see, the different is in this. You are adding you are specifying more. I mean, specifying more information that you explicitly require, right? You are talking about the stone, which is funny, and then style as well, right? So, like if you give it a go, both the poems should differ a bit. That is what my thinking is. So first response is like this. So and the second one from the Shakespeare one, like we can see it's quite different, right? Both of them are different. Correct. So this is how adding explicit information helps to change the prompting style. So then there is something called, role assignment in prompts, and it is, I will say, almost used in all kinds of prompts that we work with. Like, basically, you are assigning a role to the language model itself, right? Suppose for this, we are explicitly assigning a role of an environmental poet, right? So, like a direct prompt would be not having this highlighted sentence, right? We won't be assigning the role. So you are in a like uh, wait, let me, how do I add file? Is it possible to add file here? Uh, I'm not sure how to add file here. Does this allows? I don't think sure. Like sorry, uh, sorry for this time. I mean, right now I'm not sure how to. I don't think it's allowing me to add a file here directly. So later I will, again, just I'm after finishing, like we'll take a minute or two break before we move on to the next topic, and I'll share the IPVNB file with the host, Madam or Sir. So this is the prompt three, like if you see here, and if like let's talk about you can say you are a celebrity chef, and write a wonderful about Indian food. Let's give it a try. Indian food. So let's give it a try. So like if we see here, biryani is mentioned. I was thinking that biryani would be there, I guess. But then again, the spices that we use, that all have that been, and if we remove this, let's give it a try. I'm guessing, uh, you know, some sort of different response only. And so this time it is talking about masala dosa. So then again, these are very trivial tasks that I am showcasing you. But when you are working on NLP tasks such as summarization or translation, adding a role with role assignment usually helps. Okay. I have worked, like if you want to relate it with real life, I have worked on fake news, fake news detection using large language models. So there, if you assign roles to the language models, such as you are a fact checker or you are a historian, that kind of role-based assignment usually helps. So this is something. Yeah. Gemma does. I mean, uh, Gemma does have multiple language support. It is there. Especially like if you use a large, like if you use a 27 billion parameter model instead of 2 billion, you will get the multilingual support that you can converse in different languages uh, for Gemma. Okay, talking about step-by-step reasoning, this is what ma'am was talking about, right? Like chain of thought is there. Like, hmm, I mean, you ask explicitly the language model to describe how it has reached to the output, basically. So that is what chain of thought reasoning is there, right? So this is again like we can change the question into why is preserving water. We can perhaps say important, and then ask the language model to explain. So it is thinking like how we even think, like step by step it is thinking, right? So this sort of explicit reasoning adding helps a lot. All right, moving on, like this is a very also very important technique which is called few shot prompting. And few shot prompting means basically you explain you explain the it's few shot prompting is very important. All right, yeah, need not worry. Again, I'm saying once this is over, right away I'll share it with Shriparna madam, and she may forward it to the concerned host, and she will share with you all. Need not worry about this IPVNB file. It is very simple as well. So as I was saying, like few shot prompting is there. Basically, few shot prompting stands for, basically adding examples. All right. Researchers have done extensive experiments and figure out like for few NLP tasks, especially like classification and so on, there is something called, if you give examples to it, like correct examples to the LLM, and you ask it to follow, then the results have improved. Okay, there is a very famous paper as well called language models are few short learners. So if you look at into that paper, it is quite popular. I am not sure. I mean, it says citations in thousands. If you, yeah, so this is, it came way back in 2020. And if you could see, like, right, we have citations of 78,000, right? So this paper basically extensively proved that, using few shot learning, like adding examples, helps a lot. I mean, in, very difficult natural language tasks, the results improve substantially. All right, like even the small language models were able to, give good tackle to very large language models. Like if you see, right, the graph, if we see here, right, so you could see like the, zero shot is the, the worst one, and one shot means just one example, it is better than zero, and few shot, is, as you increase the parameters, the results are also improving quite a lot, right? So again, few shot prompting was also, a very famous technique that researchers came up with. So, in this way, this is a very basic example here right now. But then again, few shot is, so I mean, I'm not sure, like we can change it to something like what is the capital of Bihar, and we can say it's Patna. And meanwhile, what is uh, like, I mean, who wrote, like, or like we can again just, what is the capital of, like we can do a copy paste of like what is capital of West Bengal, and then based on it some sort of, or something like uh, or what we can do is let's give it a try. I'm not sure it like let's explicitly give it question two means, and like let's say it does four, like sum plus one. So if answer is 5, for example, and like if we say like like some sort of like this, like if we can, like suppose if we say $3 means 3 plus 3, which is 6, and plus 1, which would be basically 7. So also give it one more example as well. Like let's see if it can infer from it using this example, if it's able to identify the pattern. I'm not sure. So, but then again, 4 plus 4 means answer 8, and 1 9. So let's see if it's able to now answer this question. 5 means, let's give it a try. It would be a good to see this. Let's see if it's able to generate 11. I'm not sure. Okay, it's a small language model only with just 2 billion parameters, but let's see. So yeah, I mean it gave a question answer. All right, it's not able to identify. $2 means answer is like this. Let's uh, try. I'm not sure. But again, few short, when you're working like in this paper, it's a very exhaustive paper, and they have, ran so many experiments. So they were able to showcase like, this few short learning helps language model quite a lot. So, so it is saying it doesn't have information to design. Okay. Uh, I'm not sure, so it's all right. Like, uh, mm, let's see, means 5, 4 plus 1, and let's give it a try again. It would be 6 plus 1, and it would be 8 plus 1. So If we give it a try. No, it's still wrong, you know. It's saying 10, 8 plus 2. So it's not correct. But then again, you know, I'm guessing a larger parameter model would be able to identify the pattern from here. Okay. So this is how basically a few short example prompt is constructed. Okay. So moving on, constraints and guidelines are, you know, another important thing. It's like you want to use exactly 4 lines. If you remove this, I'm guessing, you know, the output would be large. So let's see. So yeah, right. I mean, it's close to 10 lines. However, if we add and, you know, exactly suppose instead of, you know, 4, like let's go for 5 lines and let's see, does it follows the constraint. So these kind of constraints based prompting is also actually, you know, same important as well. See, right? I mean, it is giving us now, it is following this 5 lines only. So this sort of constraint based prompting is equally important. So there is something called, you know, I mean, chain of thought. Researchers have basically branched it into different, different subcategories. But more or less, again, I prefer to go with the chain of thought only. But then again, you know, since researchers via experiments have proved that if you write it in such a way, the answer basically improves. So, you know, there is something called also automatic chain of thought. But then again, you know, you can say it is a sub branch only. All right. So these kind of these kind of prompting techniques helps quite a lot. So so speed equals to 30 miles per hour. It was able to calculate, right? So these kind of chain of thought again helps a lot, quite a lot. And then there was something called self consistency, right? So it is, you know, basically like how we uh, I mean uh, like you have to like you have you ask the LLM to basically generate multiple responses there, and then on based on that we work on the, I mean, ask the LLM to basically select the best one. So that is how this you know, this is how it works in the self consistency one. So sometimes like this will take you know, a bit time. So, you know, this is how, you know, it is working, like it's breaking down, you know, and uh, doing us, you know, step by step way, and like, you know, it is giving you different basically different techniques, and on that it will be like finally it will be giving you the best response and so on. So then again, as I was saying, chain of thought prompting has been sub-branched into various prompting. And when you have a logical, you know, reasoning kind of chain of thought prompting, then, you know, it has been categorized into the logical category. All right. But again, the broader umbrella is chain of thought thinking only. You know, basically, the model is being explicitly asked to reveal why it has reached to a particular output. So that is how chain of thought prompting works. Then there is GOT, you know, graph-based prompting as well. So this all ma'am had covered, right? The techniques, the ideology behind it. So again, this is, you know, how the prompting works, right? Like if you see here, like for a relationship kind of, you know, I mean, Alice is Bob's mother, okay, and Bob is Charlie's father, okay. So, you know, who is Alice to Charlie, right? So uh, Alice is Bob's mother and Bob is Charlie's father, right? So, it's able to, you know, like figure out like, yeah, okay, it is a grandmother kind of, you know. In this way, it totally depends on your use case, basically. Like the use case that you have have on your hand, on your plate is how you proceed ahead, okay? So generally, that is how this prompting techniques are utilized. Okay, there is something called retrieval augment generation. It is, I can say, a very popular topic these days. And like it is, you can say it's an entire branch on which quite a research is being done from the information retrieval technique. Example for it would be, for RAGs, like if we talk about sports domain, for example, let's talk about cricket. So, LLM that has been suppose trained on the data available till, you can say 1st May. Okay, data, it has been trained on 1st May of 2026, right? So suppose during that time, Virat Kohli had scored 80 centuries, for example, I am saying. And it's 4 August now, and in these 2 months, you can say he has scored another 2 centuries. So the data has, has been changed now, right? The statistics for a player scoring runs or number of centuries has changed, right? So you cannot from entirely scratch from the scratch, or you can retrain entirely the LLM, right? Because it cost us huge amount of electricity and money and like the resources, right? Training a good the proprietary model such as the Chat GPT or Gemini 3 or Chat GPT Model 5. So these kinds of model that we work with, take lots of resources to get trained. So what people or researchers thought, like, let's have a separate document, basically, uh, particularly belonging to these sports kind of domain fields where the data change is constant. So there they came up with, I'm just telling you the ideology. So there they came up with this, let's have a vector database that is constantly, frequently updated with all these kind of changes. And once a language model is, generating an output, what it will do, it will also look into the vector database, and from there it will get the embeddings. And it will also look at the internal embeddings that it has generated. And based on, the embeddings and the context, it would be basically looking and taking a decision that yes, this new data that I have that I see on looking at this vector database that is being frequently updated, is it the correct one, or is it, my internal representation is the correct one? And then it will choose the correct option and show it to us. So that kind of overall ideology is what is something we call RAG. Okay, so RAG again is a very large topic, and a lot of research is being done here. And basically nowadays, like whenever we open Chat GPT as well, there is a button which if you click on it, it says use web, right? Use internet to give your answer. So basically that is what it does. It looks into those active vector databases, with its corresponding queries. And based on that, it gives you a output from basically. So that is what this RAG belongs to. So again, basically, there is, I was saying the chain of thought is a very popular technique that has been again subdivided into various branches. So there is something called chain of knowledge as well, in which basically the user tries to combine two different facts. And basically based on that, it is asking to the model to derive a new knowledge. Okay. So this is an example like, water boils at 100 degrees Celsius. At the high altitudes, the boiling point of water is lower. So the question could be like, why does water boils at a lower temperature in mountains? So basically, it's trying to understand by combining two different facts and come to a conclusion that yes, I mean fact A and fact B belongs these two things, and from there I can basically infer that yeah, this is the reason for having, the answer to it. So so on and so on. Then also, I mean, when you want to, I mean, personal task that you are doing, your personal stuff, you want to write up emails post to your boss, then you want the tone to be polite, right, and respectful. So that kind of explicit emotions adding to the prompting basically helps you to, like if we like if you change it to writing a letter to my supervisor if I say expressing joy and expressing polite and respect about permission for a leave, we can say. Uh, that kind of uh, so like if you see here, this kind of adding this explicit emotion helps to change the the output more, make it more suitable to what we want. So then also there is something called scratch pad prompting. Basically, when we are dealing with mathematical questions, then in during this time, basically, like how we calculate ourselves, we ask the LLM to basically work in that way. Not LLM, I mean a language model, any language model. So these kind of prompting is also being done. So lastly, we are more or less finishing only for this piece of tutorial. So there is something called prompts of thoughts as well, like again, it comes to mathematical or programming based uh, questions like we have on hand. So then there this kind of prompting, again, you may call it, it is more or less chain of thought prompting only, but when you have a specific data set, researchers have shown that when you have a specific numerical or coding related data set, and if you do explicit this kind of prompting, the results improve. So this is how, various chain of thought prompting has been subdivided into various, uh, uh, different branches. So again, there's structured thought of chain of thought prompting. Again, you are basically asking it to have a specific structure, kind of like you are I mean defining it explicitly via steps, and so how you are able to do this. So that is how it is. And then chain of code is again I was saying related to code is code itself, right? So that is called something called chain of code prompting. And lastly, you give your own prompt. You have something already available, and you ask it to optimize. So that kind of optimization is also there. So lastly, I mean, these two again are like, rephrased ones are, you can say, I mean, more or less related to, again, I mean, just to improve the output, like to make the output better, basically, if you don't like it. So these kind of, prompts are also there, but are less used. So lastly, you are also asking the language model to be very, to take a, to be explicitly aware that it may make a mistake, and it should, look into that mistake and learn from it and do correction. So yes, so this is what I had basically. So I'll share it with Shriparna ma'am, and she can perhaps forward it. And like I'll before moving on to the second demo, I'll cover something called fine tuning. Like I have slides prepared for it. So like we can take a 2-3 minutes break here, and like we can move on to that. And again, that fine tuning again, it's completely new, a very popular research area that has been like lots of papers are coming right now, you know, and I'll like to go with the slides first, and then we will move on to the demo. The demo is a bit short on that, but again, it's important that we like at least understand what is fine tuning and why it is needed. So yes, meanwhile, like we can take a break for.
Sir,
Yeah.
can you just show me the beginning of the steps of PyTorch, like step 1, step 2?
Sorry, about what, sir? Didn't get it.
PyTorch Gemma.
Okay, I'm sharing again. So installing this.
can you just go down like step 1, step 2?
Yeah. So, sir, like basically you need to, as I was saying, you need to install the libraries. Okay. I mean, whatever library you want to work with it. If you were working with TensorFlow, it won't be here. This torch won't be there. Okay. So, and then again, you have to choose the models that you want to download. Okay. So like here it is, right? So once you download this, basically if you run this, it will be able to find its the tokenizer of the model as also the model checkpoint. Okay, from checkpoint it is, the checkpoint means basically your model has been, suppose first time it was trained on data present till 2024. So the model was stay, the first checkpoint of that model, the day on which it was trained, the weights were available for 2024. Suppose again the model was, not entirely retrained, but there was some changes made into the weights of it. And it was, again a new model with new attention weights was available on the internet of on in 2025. So that is the second checkpoint. So basically, by default, it will always fetch you the latest checkpoint. Okay. So that is what I mean by checkpoint. And these are basically, like if you go through this FAQs, it is quite simple only, right? I mean, what I have been saying so far. So again, another way to download or install the model is to use directly the GitHub link, and from there you can clone basically the repository. And once you do that, you can also, like, once you have used the GitHub repository, and then basically you can just start working. I mean, like if you see, like the Gemma PyTorch folder has been installed on your machine, and then like from here you see this is how, like from here basically the coding starts. I hope it does answer your question to some extent, sir.
Can we
Yeah,
do this downloading for all the models or
Yeah,
only
yeah,
for
yeah, ma'am.
models that
No,
are
no,
open source?
no. I mean open source, ma'am. Gemini and all that. The weight is not there, right? So how can you download? It's closed. Google, ChatGPT doesn't share this. So summarize the, I mean, the code model. I mean, basically to summarize, all you need to do is first install the correct libraries that you want to work with it, and like suppose PyTorch or TensorFlow, and then install the. I mean, I was saying like if you have defined your model here, like here you are using Gemma, right? You can instead work with, instead of Gemma, you can use Llama. Someone is on. So I was saying instead of Gemma, you can use Llama. Llama is from Facebook, right? So simple only. Once what you have to do is install the necessary libraries, call the correct model name that you want to work with it, and then just go ahead, like import the necessary functionalities. This would only change, like Gemma, instead of Gemma, it will come Llama, llama.config, llama.model, llama.tokenizer. As simple as that, nothing else. Yeah, so that is what I was saying. Federated learning, I am not sure, sir. I have no experience. I do not work on that. Federated learning, I do not. I guess it will. I mean, I am not. I do not work in it in that domain, sir. So I can't answer. So like we can take a break for like we can connect back at 4:15 or 4:15, I suppose, and I'll continue with the PPT first for fine tuning, and then it will happen. Meanwhile, I am sharing this file with Shriparna madam, and she can forward it to the host.
Okay, sir.
फॉर्म लेते जाना है, याद रखना। और कुछ नहीं मिला, इतनी को का अभी जा रहे ब्रश करने हैं।
Are you opening? Fresh with the accent.
हाँ?
Fresh with the
हेलो, हेलो, unmute your mic.
So I suppose we can start now with the second part. So we are good, right? Like we are good to start now, right? So shall I start? Sir and ma'am, all good? Okay, okay. Starting, with LLM fine tuning. So I have a small slide prepared for this. Then we'll move on to the demo. So basically, LLM fine tuning basically if we had to understand it via an example, a real life example would be like suppose there is a student who has graduated from university, okay, and he or she has broad knowledge about multiple subject, right? But when we join a company, we need to have some training for a specific job. So we can say large language models also work in a similar way. First first the language models learn from an enormous collection of book, websites, articles, from a very large training corpora. But if you want to make your language model expert in something like suppose medicine or law, or some internal document regarding to a company, we need to provide additional focus training. So this additional focus training is called fine tuning. So it is much faster and much more practical than building a new LLM model for a specific task from scratch. So that is where fine tuning comes into play. So the motivation for fine tuning is, we utilize Google Maps, right? I mean, like if you are driving, if you are cycling, or if you are walking, and if you are using Google Maps, like when you are driving, the Google Map is optimized in a different way. When you are walking, the Google Map is optimized in a different way, right? So, it adapts to our need. So we can say fine tuning is also similar thing for language model. Instead of expecting one model to solve every problem equally well, we teach it to perform a particular job more effectively. So, if a hospital wants answer using medical terminology, whereas a bank would be requiring more financial accuracy, so we would be customizing the language model for each environment so that the customer gets more reliable and consistent results without having to, train from scratch. So the challenges are again, from the introduction, it may seem very simple that fine tuning sounds very simple, right? It is without any challenges. But however, if you imagine training uh, very experienced employees for new role, and the training itself is not good, not designed in a good way. So uh, the employees may forget some useful skills, right? So same happens with this language model as well. Like we need a very good quality examples, right? Enough computing resources is also required, right? Or what will happen is that a model that gets created, may perform well in one narrow task, but then start struggling with when the input is slightly different and so on. So this kind of challenges come up, and see, so as I was saying, high computational cost, and the quality of data needs to be good. The parameter tuning, like which parameter hyperparameter value is best for your model, should be carefully studied and so on. So memory requirements for language model is again, again, like uh, if we think about, language model, one may think intuitively that the language models are limited by processing speed as well. But then again, another issue is memory. Okay. I mean, memory is very important, right? Because suppose you have to edit your huge video, suppose 2-3 hours videos on your local laptop. And you may find that editing video even on a local laptop, like which is long, just 2-3 hours, your laptop may crash, right? It may slow down, it may lag, it may hang, and it may crash. So that kind of issue is also faced by language models. Okay, because as like the conversation goes on, the memory requirements increases. So that is why the researchers spend a lot of time in processing information efficiently. So talking about here, like the example that I have shown, like if you see, I mean, even a 7 billion parameter model, with the floating point 16, I mean the storage, that each attention is stored in 2 bytes, the number of space, like memory required would be 14 GB, right? So basically, instead of floating point, if we utilize it integer based, or integer 8 based, or integers 4 based storage facility, the memory requirement to store such bits remain decrease quite a lot, right? So that is, how this memory requirement is a bit, a challenge for the researchers. So talking about parameter efficient fine tuning. So basically, this has been one of the biggest breakthrough in recent years. Uh, and it basically tells you that you do not need to retrain entire AI model from scratch. Okay, so I mean, talking in terms of real life, suppose if we own a car and we want to have a better fuel efficiency, we do not need to replace the entire engine of the car, right? We just simply replace the fuel part, or the software that controls it, more or less. So the parameter efficient fine tuning also follows the same philosophy. Instead of modifying billions of numbers inside the model, we only adjust a very small portion, and it reduces the cost by tens of times and saves time as well, and makes the language model customized as well, right? Without needing to access supercomputers or large uh, data data warehouses where you have that resources to train a language model from scratch. So talking about, steps to get a fine-tuned model is basically I mean, again, I'm keeping it in such a way that I try to relate it with a real life example and then talk about the technical parts. So if we, want to steps like learn about the steps to fine tune a model, that would be like in a way that we want to suppose we want to learn cooking. Okay. So if we want to learn cooking, I mean, yeah, we attend, some cooking school, or, take cooking lessons, and that's, we can say, something pre-training. Okay, you can relate it with the pre-training for an LLM. And then if you want to, I want to develop a bakery, I want to open a bakery kind of thing, and so I won't be going back to the general cooking lessons that I took, but I'll receive specialized training in baking, right? So that kind of uh, same journey or path is followed by a language model when it is fine tuned. I mean, it has a broad knowledge about the language and the world, and then depending on the job that we want to perform, it is provided with a targeted training. So today, when we talk about fine tuning in these times, we have two main options. Basically, either we retrain parts of the existing model, or basically we use techniques that make small and efficient changes. Okay, so this second part is the best one. I mean, it's the second option is much more popular because it saves times and money. So these are, different parameter efficient fine tuning techniques. I will be covering, I mean, the most important ones, which is the most famous one is the LoRa one in the demo as well. So need not worry. So, we don't need to remember the names. Okay. We can just think like, we have multiple options even for parameter efficient fine tuning, and depending on the situation that we have on hand, we have to go ahead with the technique that we want to work with it. Okay, so uh, again, these I have I've kept it for it may look very overwhelming, but I have kept it like to I mean, it's very simple only because over the past few years, research groups from all over the world, good, like even from academia and industry, they have proposed different ways of fine-tuning large language models. And like if you see here, though the
I have a
language,
question.
yes, ma'am.
Yes, so how is parameter efficient fine tuning different from general fine tuning? So in general fine tuning, we generally train the last layers of the to
No, no.
change the weights, and
Um,
then
no, ma'am. Again, if I had to explain from an example, I will say, suppose you have a language model and you want to do a fine tuning related to question answering, okay? But if you do a general tuning, it will be take an NLP data set with more or less, having summarization, question answer, machine translation, three different NLP tasks, and question answer would be having obviously a big more samples, and you do a fine tuning, and it would be generalized. But if you want to do a more, a deep, like if you want to do a fine tuning regarded to the medical domain, so the question answer should also belong to that question, medical domain itself. And then you are just, again fine tuning your language model on that data set, which is particularly specific to the medical question answer. So I hope you get the gist now. I mean, the layers part, what you told about, ma'am, is you like you would efficient fine tuning would be utilizing the last layers or the more important layers and stuff like that. I mean, so I hope it clears to some extent. Is it good, ma'am?
Okay, but why do we call it parameter efficient?
Because you are not change parameter, you mean you understood, it means the number of weights, right? The
Yes.
entire number of weights. For example, the previous demo, it was 2 billion, right? 2 billion parameters were there. So when you are doing fine tuning parameter efficient, instead of 2 billion, you would be changing only suppose 2 million, just 1% of it, right?
Yes,
0.1% of it. So that
the
is why it
weights
is
in the
called
last
parameter
layers of the
efficient.
model.
Correct, correct.
Yes,
It's not
yes.
always last layer. Sometimes it is from different layer as well. Again, it depends on the technique, but yeah. So that is why it is called parameter efficient, because you are only changing a small subset of the parameters and you are getting good results. So I hope
Okay.
it is.
Yes, yes.
Yes, ma'am. So I here also, if you see here, sir and ma'am, the circles are overlapping quite a lot, right? So this tell us that every, like, we need to memorize every method shown here, but we need to notice that there is variation of few central ideas, right? So like we can say it is similar to the smartphone market. We have hundred of different models, but all of them are, belong to a handful of categories based on the design philosophy. So fine tuning more or less has evolved in the same way. Okay. I mean, like the idea is to make trading faster, cheaper, and more efficient. So the first one, like adapter is, if I had to, I'll speed up a bit because I have to showcase a small demo as well. So if I had to talk about adapter, like suppose we have rented an apartment and we don't want to rebuild the walls or change the plumbing, right? But instead, what we did, we brought our own furniture and decorations to make it feel like home. So adapters also work in a similar way. Instead of modifying the original model, we add a small new component that customize its behavior. Okay, the original language will stay intact, but these additions, small additions, teach the model to perform well on a new task. So, okay, so the base model can be easily reused for different applications, and adding small add-on components will again train it for different applications type. So this is quite attractive as well. So talking about adapter pros and cons, each and every technique has its advantage and disadvantage. So, adapters, like they are very easy and cheap to customize. But again, that adding that extra components, uh, like increases the latency, because you are adding a small layer to a model, and that will also be a part when you are doing inference. So there is a small increase in the time computation cost. All right. So, and generally, since you're adding a new adapter layer, you have to be very clear I mean, where to insert it. Like you have to do a study as well. Like you have to be very good to understand where at which layer does it inserts itself. So again, these graphs show that only. I mean, like these again, I have borrowed it from different research papers. And it says that the accuracy increases when you are using this adapter based uh, I mean uh, I mean uh, techniques. So again, there is also something called prefix tuning also. All right. So this uh, sorry. So I was talking about prefix tuning. So prefix tuning is also like suppose we are giving same presentation to different audiences. So before we begin one, we may spend a minute setting the context. So like if we are speaking to school students, we will explain things differently. Like when we are speaking to teachers, right? So the presentation won't change, but it simply starts with a different introduction. So the prefix tuning follows the same idea, all right. So instead of changing the model itself, we provide it with an additional context at the beginning that will guide it how to think about the task. So that is something called prefix tuning. Talking about prompt tuning, takes the prefix tuning idea even further. Like it teaches the language model to respond better simply by learning the most effective way to ask itself the question internally. Like it is trying to find the perfect set of instructions rather than changing the knowledge. Okay. So this is also very efficient method. So, now let's talk about the main thing, which is called LoRa. Okay. When I'm saying main thing, because it is the most popular and widely used parameter efficient fine tuning technique. And it is one of the most influential fine tuning technique as well. So basically, what we are doing, if we are to relate it with a real life analogy. So basically, suppose, I am using transparent sticky notes placed over a textbook. Okay, instead of rewriting every page, I add small text, small notes wherever extra information is needed. So okay, the original book is remaining untouched, but it is now customized, right, with those specific specific notes, right? So the LoRa applies the same philosophy. It mimics the original model exactly and only changes the small set of additional weights. So this dramatically reduces the training cost and the results are very high quality. So that is why it has become the standard approach in both research and industry. Okay. So why do we like you can say adapters were also sounding quite good, right? Adapters also work good. But then the thinking is that LoRa follows instead of adding extra layers, it makes the small adjustment within the existing system itself. So that is why it runs faster. Okay, and and performs same as a adapter. So that is why it is used. I guess the host can mute perhaps the person. Uh, so talking about LoRa architecture, it is do not worry about understanding this diagram, but think of it in such a way that AI, I mean the language model is a large organization with thousands of employees. Okay, so the LoRa technique doesn't reorganize the entire company. Okay, what it will do is sorry. Hello, someone is getting a lot of noise. So what I was saying is that, if you think of language model as a large organization with thousands of employees, LoRa doesn't reorganize the entire company, okay? Instead, it creates a small expert team that will be helping to guide decisions in the specific situation. So the mathematics associated with it is, you can imagine compressing a very large image into a much smaller file without reducing its quality. We remove unnecessary information and keep the important details. Okay, so instead of storing every possible change, we will only store the most important ones. This allows the model to learn efficiently and also uh, be more efficient. How to, I mean, I'm not sure. I do Can I?
सर बस नहीं है नहीं सर मैं आखिर तक नहीं आया था सही होने गई है
क्या हो रहा है आपके रात में बस नहीं है I cannot do that, I guess. I don't have that functionality. Can you please ask the host?
निकाल दिया इसका चार्जर खो गया है बस में तो ग्रुप में बस
Can somebody directly message me?
आते हैं इधर से मेरे बस में रोज सर लौटते हैं वहीं पड़ा होगा तुमने देखा बाद में कहाँ है बस हमारी वो कराना 6184
I can't
वाली
do this.
बस
I don't have access.
कितनी देर में आएगी या दूसरी लगेगी कोई
Ah,
फॉलो करके करे
so what to do? Shall I proceed ahead? I'm not sure from where this noise is coming.
रख लिया हो वो डालने से पता लग जाएगा कि भाई जैसे किसी का वो रह गई थी बस आधे पर डाल देंगे
Hello, shall I? What to do? Shall I proceed ahead, sir and ma'am?
उसमें अगले दिन नोट आ रहा था मैं रह गई कई बार
Yes, please continue.
Yeah. So I was talking about this LoRa. Okay, so
Shubham
basically,
Singh, I will make sure you will not get a certificate. Thank you. You continue.
yes, sir. So what I was saying is that I was talking about LoRa. So basically, again, need not worry about this. Okay, I'll explain what is LoRa is. So basically, think of it in such a way that basically we understood that the weights are stored in a very large in a very large matrix, right? The attention weights, key query value matrix, we store the weights, right? So if we are doing fine tuning, so basically I don't want to change the weights of this entire matrix. What I will do is I will split this matrix into two small matrix, okay? And what I will do is, I'll take the smaller matrix and I'll make the changes into it and I'll do a matrix multiplication back into it. So in that way, there is the original weight matrix and there is a smaller a dot b's matrix that has been trained on that specific task, and using this we simply concatenate it back into the weight matrix and we get a new matrix which is called y, and this y matrix is the smarter one, right? It has been trained on the original general task as well as the small a and b. Okay, so it may sound confusing a bit, but then again the basic idea is this only, right? Instead of storing every possible changes, that would have been if we had made changes to the W matrix, which was the original one. We only store most important ones, which are stored in a much smaller dimension matrix, which is A dot B. Okay. So this is how this, the LoRa works. Okay. This paper was brought from Microsoft. Okay. So talking about QLoRa again is, you can say evolution. So basically what they did was like, they said like, let's quantize, okay? So basically what they did, instead of having a 16-bit, let's store information in a 4-bit architecture, okay? And once, like during the fine tuning, you store it on a 4-bit, and once you are loading it back onto the main machine, like to reduce, all you need to do is do a divide, right? Like 16-bit, you divide it by 4, it would be a 4-bit. And if you want to again regain the original shape and form, you need to multiply it by 4. So that is was the idea is, okay. So again, this all mathematics, we don't need to go it into the very much detail, but you must understand the ideology. That is it. All right. So like this is the like original representation, how it is done. Okay. I mean, instead of using 32-bit 32-bit representation, we are using only a 16-bit representation during this fine tuning. So basically, since the representation of the information is in the less, the memory also requirement also becomes less. Okay, so that is what quantization is. Like basically, it follows a distribution curve, and in using that, it quantizes the information. All right. So again, mathematics, it will take me another 2 hours session to explain in detail. So that is why I have just, I'm giving you a high level idea, at least to understand what this LoRa and quantization Q LoRa stands for. So basically, again, talking about people came up with, block-wise quantization, then double quantization, doing quantization over quantization, and so on. So until the results are good. So, this kind of work has been done. So, this PPT again, I would be sharing. So, going back to the demonstration, so sir and ma'am here, like what I have done here again, right now, what I have is I'll tell you like from a real life example how when you have to utilize this LoRa, okay. So basically, again, since we have 15 minutes remaining, I'll tell you what we are doing is the starting part is same only like how I showed in the previous demo. Again, I'm using the Kaggle based necessary files and libraries and the data set. Here I will showcase how to load a data set from Kaggle. One sir was asking about it. So basically what we do here is, again install the libraries, necessary libraries that we require. And then basically what we do next is, there is something called Keras. Okay, it is also a framework that contains numerous NLP machine learning based algorithms, classifiers, and so on. All right. So it's quite helpful. Okay. I mean, quite helpful. You not need to build everything from scratch. You import the Keras libraries, and based on that, whatever necessary functions you need, you can bring it. Okay. So like if we see here, one approach is, to get a like this command. If you see here, sir and ma'am, basically what we are doing is we are going to the Hugging Face datasets repository, and from there we are bringing this Databricks this Databricks dataset. Okay, and I'll showcase you. Basically, Databricks dataset is a quite famous one. It is a dataset that contains question answer. Okay, question answer. There is a question. Suppose question is like how to prepare tea. Give me steps to prepare tea. Okay. Then the answer is how a human would have responded. Like you take milk, you take tea, and you take sugar, and so on, and you boil it and so on. Once the milk is boiling, you add tea and so on, stuff like that. You take water and stuff like that. So basically, you can say instruction-based question answering data set is Databricks. It was first of its kind, and it's a very popular data set. Okay. So utilize that. You just, this is again using this wget is a command to directly fetch data set from a URL. Okay. So you can, instead of using that, you can also utilize the Kaggle based as well to directly download data set, load data set. Okay. So basically talking about the data set, once like what we are doing is, see, it is very simple only. What we are doing is this is the URL which stores the data set, and what I'm asking using this command is whatever is stored here, you download into this machine in a JSON format basically, and you name the file as Databricks Dolly 15K. Okay. So that is what is happening. Once I have that file in my machine, what I'm doing is I'm opening and I'm, just working on it. So basically what I'm doing is I'm only taking 1,000 training examples, not more than that. Because right now, my machine is limited. I don't have unlimited resources. That's why. So that is why it is limited to 1,000 training examples. And like if you see here, like this we also did last time, right? If we see here, sir and ma'am, like we are using a smaller, like last time we went with a 2 billion, but this time only using a 1 billion, language model that has been trained specifically in English language. And if you could see, like if you type this summary command, it will give you a summary. Okay. And the summary, if you see here, son and ma'am, like actually it takes time. Let me again rerun it. Let's see how much time it will take. But if you simply do this summary, it will give you everything. Okay. Like you could see the number of parameters are there, however number of parameters are there, right? So like if you could see the trainable parameters are so many, and right now non-trainable parameters are 0. Since it's an open weight language model, you can train it entirely, right? And vocabulary size also, like it has been trained with so many different vocabulary tokens it has, and so on. So moving on, suppose, since let's, like, I'll just, once give a gist of it and then I'll run it all again. So like if it was a simple, what a simple prompt I have asked the machine is, what should I do on a trip to Europe? So, it is telling about, so on whatever it has learned, since it, mind it that it's just a 1 billion parameter model. So the answer may contain this kind of thing as well. So basically, it's saying, it's giving you an answer. And then in the next, I'm asking, explain the process of photosynthesis in a way that a child could understand as well. And the response is like this, it is coming like this. However, what I am doing is, I don't like the responses right now. I want to make it more good. So what I will do is, if I have, suppose if I have a, uh, technique that will help me to do this is the LoRa one, right? And the rank here is 4, right? The rank basically is the dimension of the matrices. I was talking about, like, we split the matrix into the two smaller matrices. So the dimension of the smallest matrix would be this 4, okay? So that is what rank was to 4 here. It is generally in the multiples of 2 to the power something. So 4, 8, 16, and so on. So if you, if you like see Keras, how it is helping, like I just call the language model the backbone of it, and I am asking to enable LoRa with a rank of 4. So what it will do is, instead of taking, the total parameters, it will take a subset of parameters only, and which is this, right? Instead of 1 billion, it is taking 1 million, right? And it is taking just 3.86 MB to run it, right? So like this is good, right? I mean, and these are optimizers like learning rate, weight decay. These are, hyperparameters that you can change. There is something called, gradient descent. Basically, if you, what it tells is basically the amount of error that is being back propagated from the layer to the previous layer, that kind of techniques, that kind of information that you want to, control is where these kind of hyperparameters come into play, Saran. So basically, what we have, again, look at the beauty of it. When I was discussing the PPT, it may have sounded how many things have to be done, right, to do a fine tuning, but instead it's done in just 5 or 6 lines of code. You have loaded the model that we learned in the previous demo itself. What we are doing is we are enabling the LoRa using the Keras function that we are, the from the Keras, like I was saying, how good Keras is. This Keras, like we have already imported, and this provides us with a function which is called enabling LoRa. So basically this enable LoRa with a rank we are setting up here, and what we are doing is, again, if you look at the summary, it is telling, okay, I have fetched this subset of parameters and I will train on this. So what we need to do is, we have already loaded a data set. All we need to do is set up the hyperparameters and go with the compile function. It will, take the loss. Again, generally for this kind of fine tuning, since we are doing instruction based fine tuning, categorical cross entropy loss is good. However, if you had to do some classification, then binary cross entropy loss would have been there, and so on. So basically, you are setting the loss, you are setting the optimizer, and that's it. You are just doing a fit, right? Compile means to set up the weights and parameters, and fit means to start the training. And once it is done, basically, it will take some time, and it will take the model for the 1,000. You remember, right? We had defined earlier 1,000 samples only from the data set. So once it will train it on the 1,000 samples, and once it is done, basically, if you do uh, a new prompt, that what should I do on a trip to Europe, which is repeated from the above one, you could see the answer is now much better for a 1 billion parameter model, right? Even for photosynthesis, the answer is much improved, right? So you could see how just doing a simple fine tuning on an instruction tuned data set, which is this stands for randomness, sir. I mean, this is basically to, like, every time if you rerun the same button, the answer should come same, right? So that is what K and seeding value stands for. So let's now, since I have shown you, I hope this runs on a T4 GPU. We have, this time again, I have rerun it entirely. Now you could see the code is running. So let's hope, actually the 2 billion parameter model was failing because the GPU was crashing out. I hope the 1 billion one would be this time running. So again, meanwhile, I hope the sessions that I have took have helped you in some way, sir and ma'am. Like these are quite popular, prompt engineering and this LoRa. Everywhere LoRa is used these days, sir and ma'am. And uh, uh, like hmm, I'll
I
also,
think
I'll
yes, what you have shown is very good, but the problem is that we are running it on a very small number of parameters model, so the
yeah,
results
yeah.
would not be appropriate. So how can we do that? I mean,
Ma'am,
running it on
that I am also restricted with my constraint. I don't have access to, large GPUs. I mean, I do
no,
have IIT, but
even we don't have access. So
so
how can
that,
we?
ma'am, no, ma'am, there is no option. Like to run a good large language model of suppose 20, 30 billion parameter, you need a good machine, right? At least 80 GB of GPU you need to utilize. Like you can for ma'am, if it permits, your institute permits, you can purchase for 1 month you can purchase a paid session of Google Colab. It will allow you with a it will allow you with a I'll show you this A100. It is 80 GB GPU and it takes 60 U. So if you can, like, I'm not sure if it that allows, you can purchase it and then you can run a large language model. Like suppose a 27 billion parameter or 40 billion parameter model. Aside from that, ma'am, no option, no option. Because you can't run an 20 billion parameter model on a simple machine, right? I mean, small machine. No way. I'm not sure even this code would run right now because they have made certain changes in the policy, the web app price. So I hope, ma'am. I mean, we are constrained with our budgets, ma'am. Not
Yes,
nothing
that
much
is a
can do.
constraint, but I think anything of that sort would be useful only when we are able to train it on a large language model that contains, let's say, billions of parameters, not with 1
Uh,
billion parameters.
I will not say that is always necessary, ma'am. I mean, at least like if it has seen here what like earlier it was telling about some website, right? Like dial this number, like it was talking as a travel agent, but like once we fine tune it, the output was much better, right? So I mean, let's see, ma'am, it is running. I guess it will be able to, like if you could see, I guess this will support this time. So, okay, A100 is available in most universities. Sir, we only have one. Like we have a 200 GPU, but 50 students use it. So we are not able to run it. I mean, I'm able to run it, but there is a long queue time. But uh, we can always purchase, rent the GPUs and all that. That is what, since like Shipanda madam told you, like I was a PMRF student, so right. So I had access to such contingencies and I used to purchase um, uh, GPUs and so on to run my code. So like if we see here, ma'am, actually this code it will be able to run. I'll again, the previous code I had already shared with Shipanda ma'am. I hope she has forwarded it to the host. So uh, let's give it a. I hope this runs. But then again, sir and ma'am, yeah. So see how it is behaving. I hope, sir and ma'am, it was helpful. So like if we can see, right, sir and ma'am, even for a simple query, output is not that good. Okay, and now like since now I am starting with the LoRa fine tuning. Like I guess it will take some time since we have, even though I'm running it for just one epoch, it means, just one loop and the batch size is being one. It means the data set has been fetched, entirely on one go. So like you see, even a very simple, it says that it will take, close to 5 minutes, right? For this simple. So actually, when you would be utilizing a LoRa-based technique on a large language model, sir and ma'am, it will take 8 to 10, 12 hours, all right, for like a large language model at least. So see, in 4 5 minutes it will get fine tuned, and then but again, like this time the answer would be relatively better than this, the earlier one what we have got. So, yes, sir. That is all from my end. So I hope it was worth your time. Yes, sir, you have something to ask.
Okay, so from the participant, is there any more questions? Okay, as I see, there is no more messages in the chat box. So I will like to thank Professor Sriparna Shah Madam from IIT Patna for being so kind to take our request and conducting these two very insightful interactive sessions. I hope all the participants got real insight of these topics, and also I like to thank Raghavendra Kumar for handling this current session and explaining all these things in very detailed, right? How to use prompt with JMA and all. So it is really interesting, and yeah, again I thank both of you. And with this, I end today's session here. There is no more session today. Thank you,
Sir?
everyone. Yes, yes.
Sir, where is the attendance link?
So today onwards, we are not going to collect the attendance manually on Google Sheet. We will collect the attendance from WebEx itself. Okay.
And sir, what about the quiz and another assessment?
When quiz will happen, we will notify you. No, yes, with a separate mail that today there is a quiz, or before
Okay,
one
sir.
day
Okay.
you will get a mail. Okay. So don't worry about it. Okay. So any other doubt to me? Any other questions from anybody?
Hello, sir.
Yes, yes, yes.
Sir, I have one question regarding this FDV program.
Yes, please.
Sir, actually, I'm a student and I'm attending this.
Very
So,
good.
hello.
Yes, very good.
So, sir,
Hmm.
so regarding the certification, so
Yes.
I was asking that will I be getting a student certification or a faculty certification?
No, you will get a student certificate. Okay. You will get a student certificate. It will be written like UG student. Okay. If you are a UG student, or if
Thank
you
you.
are a PG student, it will be written PG
PG
student. Okay.
student, sir.
Yes, yes.
Thank you, sir.
Thank you. Okay, it seems there is no more discussion from anybody. Okay, many of you are raising your hand. You can just unmute yourself and speak up. Animesh Shamanta. Dr. Animesh Shamanta is raising hand. Okay. So thank you, everybody. See you again tomorrow.